Hello, and a huge welcome to all the lords, ladies, and common folk of Northcoders Shire, and all the surrounding shires. It is our great pleasure to have you witness our third remote graduation. We could not be more proud of the work that our students are presenting today. I've witnessed some of the tears, blood, and wine that has been spilt over the last 3 weeks or so, as the people you're about to see prove that despite social distancing, we are all still able to come together to create great things. They have not only our congratulations, but also our thanks for all the positive spirit and constructive feedback that has helped us transition in this difficult time to help form a conclusion to their time on the course that might be unexpected, but hopefully still does a service to their efforts and achievements. To avoid any live technical hitches, we've recorded all the contributions, but if you're watching this live, they're all living alongside you and would love to read your comments and respond to your questions. We ask that you please make it really clear in your questions which group you're talking to so the right people respond. If you're watching after the event, we'd still love to have you share your thoughts, queries, emotions, exclamations, and emojifications in the comments. I shall prepend this event no longer. Please give an enthusiastic virtual applause to our first team, the Butterfly Hunters, and their project, which transports me back to my pre-teens, innocently gambolling around the Sussex Downs, engaging in all things Lepidopteran, Butterfly Hunt.
Hi, my name is Conway, and along with my teammates Norbert, Harriet and Rob, we are Butterfly Hunters. Today we would like to present to you our Augmented Reality web app built in Vue, A-Frame and on a Firebase backend, Butterfly Hunt. Butterfly Hunt was really conceived of in response to conditions brought about by the COVID-19 epidemic. We had the sense that people were feeling understimulated and very anxious, so we wanted to create an app that would bring a bit of colour, wonder and fun to people's days. We were also thinking about parents of young children who suddenly had full-time childcare responsibilities. So we wanted to create something that would give children an activity that they couldn't currently do outside, like hunting for bugs. We also wanted to create something that was involving and interesting enough to occupy them and maybe give their parents a little bit of free time. Finally, Butterfly Hunt is really a culmination of ideas that came from every part of our team. One team member was particularly passionate about quarantine quality of life ideas. One was interested in game design. Another was really excited by making engaging apps for children, and one was extremely interested in augmented reality. We got a chance to combine all of these things and make a really cool app. And now I believe Harriet's going to give us a quick demo.
I will now be taking you through a short demonstration of our app, Butterfly Hunt. As you can see, you are able to view how to play the game before creating an account or logging in. It will display a list of instructions and visuals on the page, from creating an account to downloading the markers, placing your markers and hunting for the butterflies. This page is accessible throughout the app in case the player wants to refer back to anything they were unsure about. If you don't already have an account, click Create an Account and it will take you to the sign up page. You will need to type in your email address, username, password, and confirm your password. Once all those boxes are filled in, click Sign Up and it should indicate that you have created an account. Now we will go back to the login page and use the email and password chosen when creating an account, and this will take us to the parent profile. On the parent profile, you can see that you can create a new player for your child by clicking on New Player. When clicked, it should show an option to type in a username. As you can see, choose a default avatar from the list, or if you have a custom user image, you can post the URL in the bottom. But for now, I will type in Jess Jelly as the username and choose a default avatar image. Once you have clicked Create Profile, the new player should appear at the top of the page along with the chosen username. When you click on the player, it should navigate you to the child profile. From here, you can either click on Butterfly Collection or Go Hunting. If you click on Butterfly Collection, it will show you a list of butterflies along with their name, type, and how many times you've caught that particular butterfly. The butterflies are displaying black silhouettes for the time being because they haven't been caught yet. If we go back to Jess Jelly's profile and click Go Hunting, Your camera should then display your current environment as it is doing here. Luckily for me, I have a marker right next to me that I can scan. Once we point the camera at the marker, the butterfly should appear, and when the target changes to green, you should click on the butterfly and it should display a message that you have caught it. Now, if we go back to Gesture's profile, click on the butterfly collection, and that said butterfly that you caught should be lit up, and it should show the type of butterfly it is, along with its information and how many times you've caught it. I will now pass you on to Norbert.
So I was mainly responsible for the augmented reality side of the project. I used a framework called A-Frame, which is built on AR.js. Its main function is to render the butterflies in the 3D space when you introduce a marker such as this to your camera. Our game has 5 markers built into it, and each marker gets a butterfly randomly assigned at the start of the game. Positioning and scaling was definitely a challenge in A-Frame. We had to meticulously calculate it of where the butterfly shows up based on this marker. You also see a cursor in the middle of your screen that's there to help us and to help you catch the butterfly as well. When the butterfly comes in the scope of the cursor, you are able to tap on the screen and catch that butterfly. Behind the scenes though, it will send a post request to our database with that butterfly's info, so we know exactly what to show in your collections page. In other words, we know which butterfly you did catch this time. I also went away and learned about a program called Blender, which is to do with 3D modeling. So each of the butterflies that you see are handcrafted and hand painted by yours truly, and I think they look terrific, but I might be biased here a little bit.
After having previously spiked numerous technologies, including Angular and Vue, my group and I decided to use Vue as the front-end framework instead of using React, which was familiar to us all, but we wanted to explore new tech and challenge ourselves to learn a new framework in the time frame that we'd been given. While Angular and Vue both had their advantages, I was aware after researching about Vue that it was increasing in popularity and it has an overlap with React and Angular with respect to their functionality like the use of components. I thought the transition to Vue from React would have been a better option, and we were all excited to learn this lightweight, fast-growing framework.
Hello, my name's Rob and I'll be talking about our choice of database, Google's Cloud Firestore. Firestore is a hosted NoSQL database storing information as documents inside collections. As there is no ability to join data together, the way the documents are nested under each other in sub-collections must take into account how the data is going to be used. This is something we had to think through at the start of our project. Firestore promises faster read times at the expense of slower write times and less flexibility when making queries. As our project didn't require any complex queries, we thought it would be a good fit for us. Access to the database is regulated by the rules set inside the Firebase console. When a user logs in, Google places an authentication token into your browser. And one of the challenges we encountered when using Firebase authentication was simply realising that the requests to the database automatically carry these authentication tokens along with them. I'll now pass you over.
I'm going to discuss the issues my group and I were concerned about whilst completing project phase remotely and the Agile-inspired practices we tried to implement to get around these issues I'm now going on to discuss. My group and I were initially anxious about pair programming and how to communicate with one another when someone had bad internet. We did try and use VS Code Live Share, which was very useful when somebody was stuck on an issue and they needed somebody to just jump in their code and try and help them out. We also had 2 stand-ups, one in the morning and one in the afternoon, to make sure that we were up to date with what everyone was doing. And we created a group chat to make sure that when somebody had bad connection with their mic issues, they were able to communicate with us by messaging us. We also used a Trello board on the internet, and that allowed everyone to keep track of where somebody was at in regard to the front end, the back end, and A-frame, and whether we were keeping pace with the workload and the time frame that we had. Overall, I think these agile inspired practices made sure that we were on track and hopefully helped us to enjoy the process of project phase.
So we did have a few challenges on the way. Very early on we realized that we're not going to be able to make a native application as we originally wanted to. This was due to hardware limitations of running Android Studio efficiently. So although it was a difficult decision to make right at the beginning of project phase, we opted for a web application and the finished product turned out great, so we definitely made the right choice at that point. Another big challenge was to actually make augmented reality happen in a web application. When you look at native applications, they have tons of options to choose from when it comes to augmented reality. They have loads of programs to use, they have up-to-date documentations and tutorials, but when you actually look at a web page and wanting to display augmented reality through a website, it's still very much in its infancy. There's not many use case examples out there, so there's no go-to programs to use. And the framework that we chose, A-Frame, is actually built with virtual reality in mind and in the first place. So all of its documentations and all of the tutorials out there are for VR. We had to really dissect the information that we could find online and piece it back together carefully so we could give you a good user experience when it comes to augmented reality. We wanted to have the feel and the look of a native app, but brought into life in a web page.
This was a very front-end heavy project, and I personally did quite a lot of moving around between Vue.js, AR.js, and A-Frame. We identified pretty early on that one of our obstacles was going to be integrating these new technologies with each other. In particular, Vue.js, as a component-based framework, really struggled with AR.js, which, as a library, could only be imported into the script tags of a vanilla HTML document. I think this would have caused us integration issues no matter what framework we were using, but if we had been with something like Angular or React, which have much more widespread use in the West, then I think we would have had a better chance of finding someone else on the internet somewhere who had had the same integration issues that we were having. As it was, we were working in very young web AR technologies and a very niche framework, and trying to find anyone who had kind of done this before to share their insight on the internet was all but impossible. So with a lot of these problems, we were alone in the wilderness.
There's a few things I would like to do differently. If I were to start over the project today with what I know now, I would definitely try and make this into a native application. Now, we had some hardware constraints of not being able to run Android Studio, and despite that, we turned out a finished product that kids and parents can enjoy as it is. But I do think it's in the back of my mind to think that had it been a native application from the get-go, it would have been just a little bit more impressive to look at. And another thing that I would really wish we could explore further is these markers. So we went for some very simple markers that are easy to recreate if you trace it over your screen, or you can just print them out. But the initial goal was to create markers that are just very simple geometric shapes, like a circle or a cube or just a line that you could draw in a matter of seconds, and then you could hit the ground running with our application. Unfortunately, it wasn't something that we was able to do in the time that we had for it.
Personally, my favourite things about Butterfly Hunt are the ones that make it accessible. I love that it's a web app that will run on the oldest and crustiest mobile devices, including all of mine. I love that our marker designs are simple enough that we were able to hand draw them traced off our screens and have them still work perfectly. I love that this means it's accessible to people who don't have the newest phones or who don't have access to a printer. And the big item on my wish list that we worked really hard on but just couldn't crack was to do with accessibility and the readability of how text displayed on that moving, dynamic, augmented reality screen. We tried really hard to put static frames behind our text as it displayed so that we could control how much contrast there was between the words and the background, so that people who maybe don't have the best eyesight would be able to kind of access and enjoy the app in the same way as everyone else. Ultimately, this was something that we worked really hard on, but I believe there's something to do with the way that the text frames were displaying in 3D space that we just weren't able to crack in time. And I hope it is something that we're going to keep looking at and fix. Finally, from all of us Butterfly Hunters to you, a massive, massive thank you to everyone who's tuned in to watch our presentation. We were working with an almost entirely new tech stack here, and we're really proud of what we've built. We hope you enjoyed learning about it, and we really hope that you'll go try it out for yourself at https://butterflyhunt.co.uk. Thank you so much.
Congratulations to the Butterfly Hunters, and thanks very much to all of you who've listened and engaged. Just to remind you that you're more than welcome to keep posting questions, just make sure it's clear they're targeted for that team and they will field them. Next up is the Three Musketeers with their app HelpingHand. Like most good apps, it's very much an idea born out of the moment, the usefulness of which will endure much beyond our current circumstances. Please make your welcome vociferous.
Hi, I'm Katie.
Hello, I'm Judith.
Hi, I'm Conrad, and this is HelpingHand. HelpingHand is a cross-platform mobile app that we've created which aims to pair up vulnerable or elderly people who can't or would otherwise struggle to leave the house with volunteers who are able to do their shopping for them and drop it off. The idea came about in light of the current coronavirus lockdown, and we've taken it from idea to working app in about 2 weeks.
I'm now going to be talking briefly about our planning and development process. The first step to our planning process was to come up with a set of user stories for both the volunteer and the vulnerable person, so that we had a really good outline of what functionality we wanted the app to have. Then before moving on to coding, we used Adobe XD to produce a very rough wireframe of the app and used the prototyping feature to help us figure out the user journey through the app, which gave us a really good base when it came to coding, as we knew exactly where everything was going to go and the type of experience that the user was going to have. So I'm now just going to move straight on to a demo of the app. I'm now going to show the demo of HelpingHand on an Android device from the perspective of someone who needs help with their shopping, in this case, Mr. Wilson. So I'm going to go get started and get him registered by clicking Help Me With My Shopping. And I'm just going to quickly whiz through this registration form. We need to also ensure that it's a valid postcode. And there's also a disclaimer at the bottom here because we need to share the name and approximate location with all potential volunteers in the area so that the volunteers are able to specify a radius. And the user's phone number and exact address will be shared, but only with the person who decides to help them. And this must be ticked in order for you to register. So I'm going to go ahead and do that. We're now going to log back in as Mr. Wilson. He doesn't currently have a shopping list, so there's an option to take a photo or choose from the gallery. I'm going to show you that the camera functionality we have is a working camera. So this is the point where there would be a shopping list and you would just grab and take a photo. At present this is just on an emulator, so I'm not able to show you the actual camera view. So for the purposes of this demonstration, I'm going to choose a photo from the gallery. We can also crop this image here if we want to, so that it's a bit easier to see. And add your image uploads the image. When we click see my shopping list, this takes us back to the overall dashboard, which shows the status of pending and today's date when we sent in the request, and that it's currently waiting to be picked up. I'm now going to take you over to Judith, who's going to show the app from the perspective of the volunteer.
HelpingHand works both on Android and iOS devices, so I will be using an iOS simulator to show you the app from a volunteer side. I'm going to click I'm here to help. Our volunteer will be Dennis, who can help Mr. Wilson with his shopping list, so I'm just going to register him quickly. On the slider, the volunteer can set the size of the area where they want to help out, which by default is at 5 miles. I will set it to 7 miles. I'm just clicking register now. If the user forgets to fill out a field, the app will not let them register and show a little message. So I'm just going to enter a phone number as well. And click register again. After registration, the user is taken to the login screen where they can now log in. Here, the volunteer will see a list of all the neighbours within the given area who need help with their shopping. We have Mr. Wilson at the bottom, so I'm going to click on him to see more details. We can now see the option to pick up his shopping list, the shopping list itself, and also Mr. Wilson's approximate location, which we can also open on our Google Maps. It's important that at this stage we are not giving out Mr. Wilson's address yet, only an approximate location. I will now scroll back up and click I can help. Since Dennis is now committed to the shopping list, he is able to see Mr. Wilson's exact address and also has access to call his number to arrange delivery once the shopping is completed.
Now heading back over to Mr. Wilson when he logs back in sometime later. We will be taken back to the dashboard where we can now see that the status has changed to accepted. We can see that our volunteer is called Dennis and he's currently helping us with our shopping. If we want to check on the status of the order for any reason, we can just click to call Dennis down here and that'll take us to call him directly on the number he's provided. So let's head back over to Dennis and watch him complete the order.
After completing Mr. Wilson's shopping and arranging safe delivery, Dennis can now mark the shopping as delivered. This will also show up on Mr. Wilson's shopping list dashboard, where he also needs to confirm that the shopping was indeed received before the shopping list gets marked as fully completed in the system. The volunteer is then taken back to the list of other neighbours who need help with their shopping. Thank you for watching our HelpingHand demo. We hope you liked it as much as we do. Now I'm going to talk about our tech stack. Apart from Express and Node.js, all other technologies that we ended up using were 100% new to us, none of which we learnt about throughout the course, so it was quite a nice challenge to pick up on within the 2 weeks time frame that we had to learn these technologies and actually build our app. On the backend, we built an Express API server with GraphQL, which was a good alternative to REST endpoints for handling HTTP requests. For our database, we used MongoDB with Mongoose. We chose GraphQL and MongoDB because we were quite keen to learn them both, given their popularity and because they were quite different from what we learned in the course, which was SQL with Postgres. We also used bcrypt to hashing passwords and also for basic authentication for when our users log in. We used 3 different Google APIs, 2 at the back and 1 at the front. The backend ones were geolocation to get the coordinates of each user based on their postcode, and we also used the distance matrix API to filter the shopping list based on the volunteer's location and the given distance they were willing to travel. On the front end, we use Flutter, which is a framework by Google, and it's written in Dart. So first we had to learn a new programming language, which was Dart, to be able to then pick up Flutter. The third Google API that we used in the front end was Google Maps, which was to display the approximate location of our users in an in-app map. For the image storage, we used Firebase, where we sent off the actual image from the front end and then linked the image URL to the user document in our MongoDB database. We deployed the backend on Heroku, and for version control, we used GitHub. Now I'm going to pass you over to Konrad, who will go into more details about the backend technologies and why we chose them.
In terms of our backend tech stack, we went with MongoDB for our data storage, as non-relational databases, along with MongoDB itself, was something that we hadn't tried before and we were eager to explore. We also used the Mongoose framework to work with MongoDB within JavaScript. As it turns out, our data lends itself pretty well to non-relational databases, although it would work fine on a relational one as well. One nice benefit of using MongoDB is that the data is stored and returned essentially as a JSON object, which made it quite easy to work with, as well as pairing nicely with GraphQL, which we used to build our API. We chose GraphQL for the API because, again, it was something that we'd never tried before, and we decided quite early on that we wanted to explore a lot of new technology with this project. One thing that drew us to GraphQL is the ability to specify exactly what you want out of a request, as well as exactly what you want to put in. This meant that we could cut down on both data transmitted per request as well as the number of requests overall. On top of this, it streamlined development in general because at every point we knew exactly what results we were going to get back from the API request. So we didn't have to worry about sorting out the data that we needed from the extra data that might have come from a more rigid request structure. Another thing that was a nice bonus from using GraphQL is that it comes with a built-in user interface called Graphical, which provides like a sandbox environment for rapidly testing and iterating on API queries without the need for any extra software. This made developing the API a lot quicker and easier. For the map and location functionality, we went with Google Maps via Google's cloud platform, mostly because of the large suite of APIs the platform offered. Everything that we needed was provided by these different APIs that were all working in the same ecosystem, and they were all designed to work seamlessly with each other, so it seemed like the logical choice. For example, when a user is created, a request is sent to the geocoding API with the user's address, and the location data returned from that is already in the right format to just send straight to the distance matrix API, which is used to get the distance between multiple user locations for filtering purposes. Finally, we went with Heroku to host the backend. This was one place that we did kind of play it safe, as we already knew that Heroku was a reliable and affordable hosting platform that fit our needs and would do exactly what we needed to do. And now I'll pass you back to Katie, who will go into a little bit about the front-end tech that we used.
Great, I'm now going to talk to you about the tech on our front end. I think we knew from quite early on that we wanted to develop a mobile app. Our project lends itself well to being a mobile app, and we also wanted it to be device agnostic, so we started looking into technologies which fit this bill. We came across Dart and Flutter, which can be used to develop apps for both iOS and Android. It was great to use Flutter and Dart because it gave us a chance to explore an object-oriented programming paradigm, as opposed to having most recently used React on our course, which is based on functional programming. Flutter is also a Google product, and hence we chose to use a Google suite of products, as they have excellent integration with each other and are, in theory, easier to set up. As you saw earlier, we use Google Maps on our front end, and we also use Google Firebase Cloud Storage for our shopping list images. We use Flutter GraphQL plugin, which allowed interaction between our front end and our backend GraphQL endpoint. I think it's fair to say we had a few challenges with this, which we'll explore in more detail later on. I'm now going to pass you over to Conrad, who is going to talk about the Agile practices we used throughout our project phase.
From the beginning, we went into this following Agile development practices. We had a Trello board that we kept updated consistently throughout the day. This was especially helpful for us as we were working completely remotely, but we could still see it updating in real time as we ticked off things that we'd done, moved tasks into different states of completion, and so on. Doing this meant that everyone always had a handle on what was going on as it was happening, so we were always up to date with each other. We also had multiple stand-ups a day, usually 3, sometimes more. We used the Discord server provided by Northcoders for this, as it's a super easy platform to just drop in and out of, and it worked really well for what we wanted to do. Having these stand-ups meant that everyone was consistently kept up to date on what everyone else was doing at that point in the day, along with any challenges that people might be facing. And this was great because sharing the challenges that we'd run up against with each other gave opportunity for each of us to offer help where it might not have been immediately obvious that someone was struggling had we not had these meetings. And finally, we also practiced both pair and mob coding throughout the project. We employed pair coding throughout, which was really helpful, especially on front end for tackling what was basically an entirely new language, framework, and development platform. And for both front and back end, we initially mob coded both of them for the first few days, and this gave us all a good footing of the sort of foundation of both sides of the app. And now I'm going to pass you over to Judith, who's going to talk a little bit about the challenges that we faced working on this project.
Not so much a challenge, but an important factor that during the 2 weeks we encountered some illnesses in the team, and we were already down to a team of 3 people because unfortunately we had someone who had to drop out just before starting the project. The 3 of us also have never worked together before, although we were doing the same course, we just never ended up being paired up. So first we had to actually get to know each other a bit more and our strengths and weaknesses as well, and overcome some communication challenges at times. To do that, we started off with learning together, which leads me to our next challenge of picking up a whole set of new technologies. We would start off alone, reading through a bunch of documentations and watching tutorials on our own, so then afterwards we could then group up and do some mob coding of parts of our application together before splitting up to focus on different areas. Working remotely but together as a team was also a challenge, partly because we never actually had to do that before, and partly because we had some technical challenges as well. Between the 3 of us, we had both Mac and Linux, which weren't always compatible, or things just didn't work out as we expected them, like the mobile simulators just would not work on one of our machines. Our solution to all of this was that we did a lot of video calls on Zoom to have a face-to-face contact that we would otherwise have had in person. We also did a lot of calling on Discord and Slack. We were pretty much constantly available there to be able to listen to each other and help out when someone was struggling. We also did a number of daily stand-ups, and we did a lot of pair coding with VS Code's live share extension, which lets all the connected parties type into the same code as we would have otherwise did that in person. We also kept a close eye on our Trello board, making sure that any bottleneck tasks were completed on time so that other parts of our application could also progress. We reviewed our deadlines, we kept a track of each other's work and jumped in if help was needed. The last challenge to mention was integrating Flutter with GraphQL. The library recommended to do this was only a 1.5 years old and recently just had a big update in January, which meant a lack of available resources as the ones that we found were all outdated. As a solution, all 3 of us jumped on the issue and did some extensive research, including looking into public GitHub repos, which had real-life examples of using our plugin. And now at last, I will pass you to Katie, who will tell a bit more about the future outlook of HelpingHand.
I'm now going to talk to you about the future outlook of HelpingHand. As you know, we had only 2 weeks to deliver this project, so I think there's a lot more we would love to add in the future. Some of these are image to text, audio to text, and a web app for typing in a list as different ways of interacting with the app to make it more accessible. One of the main things we would look to add is an in-app payment solution. We're currently assuming cash could be left in an envelope on delivery. However, we are encouraging a safe exchange at a distance, and an in-app payment solution would fully facilitate this and make it more secure. To add more security to the app in future, we would look to implement a rating system and perform security checks on volunteers. We'd like to say thanks to everyone for taking the time to support us. We really appreciate it, and we have been really excited to share our app with you. Without further ado, we'd like to open up the Q&A session, where we'll be answering your questions live in the chat below. Thanks for listening.
Thanks again to the Three Musketeers. I'm sure you are impressed by how well that was executed. Keep those questions coming. Next up, diversions are what we all need at the moment, and they don't come much more diverting than our next app, MovieMapStar. Please welcome, all the way from the right-hand side of the Pennines, Team Right Side of the Pennines. The right is purely geographical.
Good afternoon, my name is Paul. My colleagues and I would like to demonstrate to you the app that we've been working on remotely for the last 3 weeks. The team consists of myself, Vanessa, Philippa and Justin. The app is called MovieMapStar, and the idea behind it came from an article in which some students had planned their entire world trip based around their favourite filming locations. The purpose of our app was to help a user create a route based on their favourite filming locations, take pictures there, share them with friends, and then review the locations that they visited along the way. The app itself gave us an opportunity to work with AWS, Google Maps and the camera, and some other technologies that we've not had experience of using through the course. I'm now going to hand you over to Philippa, who's going to show you a brief demonstration of how the app works.
Hi, I'm Philippa and I'm going to be talking you through a demo of our app. So I'm going to sign in as a registered user. And the first page that the user is taken to is their profile page, where they see their avatar, their favourite films which they selected when they signed up, and any badges they may have earned. I'm going to head straight over to the map. And here the user can view any film that was filmed in the UK and see where those filming locations are. Now, the first marker that's rendered on the map is the user's location, and I'm going to look for Harry Potter films. And I'm going to click Find. So on the map, we see all the Harry Potter locations filmed in the UK. And because we're based in the north, let's have a look at some of those northern locations. If I click on this one, that is in Alnwick. We're given the address and also the option to select the destination. So before I do select it, I want to find out what scene exactly was filmed in Alnwick. So I'm going to click on View Movie Information, and then scroll down to the bottom to show it there. So Alnwick Castle is that location, and the scene that was filmed there were the broomstick flying lessons. Lovely jubbly, let's head there. So I click Select Destination, and there we have the route rendered on the map from my current location, and we can also see the text directions giving me instructions on how to get there. I'm going to hide those and hide the movie information. Now, as you can see, there are several other locations that would be on my way to Alnwick. I'm going to select this one just here. Goatland, okie dokie, I want to just see what was filmed in Goatland so I can show the movie information. And that looks like, Goatland Station, Hogsmeade Station is what was filmed there. Lovely. So I'm going to add that as a stop, and we can see that the route line has changed on the map. Now, we wanted to make this app a little bit more interactive, so if we head over to the camera, we chose to add this functionality so that when users arrived at their destination, they would be able to take a photo of what they saw, but also to be able to reenact a scene and take pictures and have that stored in the gallery. So even though I haven't travelled all the way to Alnwick or anywhere, I'm going to pretend and I'm going to take a picture of my back garden. And when I have taken this picture, this will be added to my gallery, which I can have a look through. So my previous location pictures are rendered there. As you can see, I have been very busy, and so are the images that I have just taken. There we go. I'm now going to pass you over to Justin and Vanessa, who are going to talk you through our tech stack.
Hi, my name is Justin. I'm going to be telling you a bit about the back-end technologies that we used for our project. So AWS was the main choice of everyone. It's quite exciting, it was challenging, and it offered some really good features that we used throughout our app. The AWS features that we used were API Gateway, Lambda functions, DynamoDB, S3 and Cognito. So API Gateway, that allowed us to create the API with multiple endpoints and sort of work towards an MVC pattern. We used DynamoDB, which is a great database. It's a NoSQL database. It's really flexible and it was really easy to use and really helped us with planning. It also interacts well with Lambda functions. So Lambda functions, you can have integrated testing. So when you do a web request, an API request, the data that comes through needs to meet a certain criteria, and that was great because it made sure that whatever the app was doing, it was functioning well with our database and database tables. We used S3 for the images, so the user would go to a movie location and take a bunch of photos. It would have a gallery, and S3 was great for this. It was just easy to access, and the data came back quickly. We used Cognito, so Cognito has the authentication side to it. It allowed us to verify users, so you'd sign up, an email would get sent to your email account and you'd have to verify it. It allowed us to handle the login really well and securely, so that was good. And lastly, the Lambda functions, it was there to manage API requests, and again the integrated testing was really good. It just made sure that everything functioned well with our database. So how this app would work from a technical point, a new user would be required to sign up with a username, their name, password and email. On sign up, Cognito would send an email to their personal account, just trying to verify that the email exists. Once this comes through, on sign up, an event, the Lambda function is actually triggered, and a new user is created in DynamoDB and a new profile is created. The user can then sign in. Once you've signed in, their interactions with the database are sort of carried out by Axios requests to trigger Lambda functions to update your profile, to delete something in your profile, or to fetch your profile, to fetch your movie preferences, to change your movie preferences. The next bit really is the images. So when a user selects the camera feature, because we created a progressive web app, we had a bit of a problem. So we couldn't use the S3 features as they are. We had to use HTML5 camera method, which allowed us to use a desktop camera. So what that means is that now when a user does use the camera, we create a base 64 file. So the image is a base 64 file, and then that gets processed up to S3. When you want to go into gallery, we then invoke a function that calls the S3 bucket by the username and returns all the images into a gallery, and you can go and see what you've been up to.
Hi, I'm Vanessa, and I'm going to be talking about the front-end side of our project. Considering what we had envisioned, an interface that would allow a user to plan a route based on a movie's filming locations, we knew our choice of framework had to fall upon something that was reliable, that would allow for a certain degree of complexity while still being responsive, and that would allow us to create a dynamic user experience. For these reasons, we decided to use React. As far as design goes, we decided to go with Material UI, since this interface library is stocked with React components, so we thought it would be a nice fit for our project. Both a visual and a functional element at the center of our app, the map was created using Google Maps API, and then we used some logic on the back end to build a bridge between the Google Maps API and the information we wanted to get from the Internet Movies Database API we were using, so as to display the information for the user on the map.
One of the issues we faced during production was the amount of technical documentation we had to read. None of the group had used Google Maps API or AWS before, so this was initially quite intimidating. However, it quickly became apparent the potential of both, and both were eventually used in the final app. Remote working was also quite challenging due to connection speeds at busy parts of the day. We decided as a team to have our stand-up sessions very early in the morning and in the late afternoon. We also had a Kanban board, which helped us stay focused and keep track of any outstanding tasks. We also use VS Live Share to pair code whenever possible.
Despite our initial planning, there were some user stories that we were not able to include in our project at this point. Nonetheless, we did keep a record of the elements we would wish to include had we had the time. Some of these elements are an Around Me feature, so as to show movie locations around the user's location, which we could not do at this point due to some limitations in the API we were using. Another feature we would like to include would be to not only use the user's location to show him locations around him, but also locations that are relevant to the user by making use of the information in his profile, such as movie genres that the user prefers. One of our last topics was to add social elements to our app, such as the ability to be able to rate a photo or a location and allow users to interact with each other in that way.
That's the end of our presentation. If you've got any questions, we'll be answering them in the chat.
The City of Leeds have churned out many enduring greats: Marks and Spencer, Cluedo, Gabby Logan, and now MovieMapStar. May your efforts be forever etched in the cobbles of the hedgerow. Finally, a tad more diversion. Team Quarantine, that's right. A team after my own heart with their decision to meld together two of my loves, words and play, in an app they've put together called WormPlay. That's right, it's a play on words that you play on worms. Please show your love right to the very end and then head off for a very, very well-deserved whatever it is that you are doing next. And remember, though we may not embrace, our hearts are closer together than ever.
Hi, I'm Patrick, and I'm from Team Quarantine, and we're here today to tell you about WormPlay. WormPlay, it's a play on worms. And what is WormPlay? Well, our initial concept for WormPlay was, what if you could take a popular word game that for copyright reasons will remain unnamed, but instead of putting your letters onto a boring, unmoving bit of cardboard, you could drag and drop letters onto a moving cartoon worm. That sounds pretty good, right? But WormPlay is also so much more than that. WormPlay is a two-player online game that uses WebSockets to feature real-time interaction between players. It also has a lobby system where players can sign in with a username, and then they can meet up with friends, create new games, or they can just challenge a random stranger to a game of WormPlay. And last, but certainly not least, you can put your own face onto the worm. And if that doesn't make you want to see the gameplay, I don't know what will. So on that note, I'm going to hand over to James, who will walk you through the game.
Hello, hi, my name's James, and I've got the great pleasure of talking you through our WormPlay demo today. So this is our login screen, and here you'll be putting in your handle that everyone else will see for the rest of the game. So I'm Lone Star, the fastest worm in the West, and I'm just going to jump in quickly. Now, here is our lobby. It's dynamically generated through sockets, and you can create your own room and join in. So I'm just going to create one here. I'm going to call it the Alamo, because I'm a Texan worm, and I'm just going to create that now. And this is a basic overview of how the game works. You can see our room here at the Alamo. We have a live chat system, and up here are a number of tiles that you have to drag and drop onto your worm. The goal is to create the longest worm and submit it within the time limit for the most points. There are two worms, so you do have to play it against an opponent. So I'm going to leave this game and go join a game that my friend Nadia has set up over in Newtonville. Now, some of those eagle-eyed amongst you will notice that we do have some facial recognition going on the right-hand side. So what you can do is pull a number of silly faces, and they'll display on your worm, and then any faces your opponents take will display on their worm, so you can see each other. So I'm just going to pull some faces now. So I'm going to do happy, shocked, angry. Oh no, not Is that angry? Yeah, that's angry and sad. And I'm just going to join in with Nadia there. It's always a lot of fun making those. Just loading up the game now. So as you can see, I've got my happy face there and Nadia's face here, and I have to drag and drop a word onto here. So I'm just going to do. And as you can see, when I drop it down, Nadia's face changes when I drop it down. So I'm just going to submit do for 2 points. And I'm not sure Nadia's got anything. Oh, she said B. So she won that round. As you can see, my face has gone to sad for the in-between of the round, and it's currently staying sad because Nadia has a higher one than me. So I'm going to try spell the next one. So I'm just going to do Met. Oh, God. So the music score in the background was composed by our person, Patrick. And I win with Met, so it's 1 apiece. And you can see our faces have gone back to happier side. But our facial capture system has me looking a bit gormless over there in the side. And I'm not quite sure what I can spell with this one. Maybe moo? Or mop. Mop might be good. Or should. Nadia is very good at this. She does pay about 26 hours of crosswords a day. So she is pretty lethal. We do have a scoring system, so it goes off to an API and comes back, and then different words or different letters are weighted for different values. So sometimes you can clip someone with having a more complicated word in terms of how few the letters show up in the English language. And sog, dep, des, d, like the German there? No. So it's a draw. Not sure why Nadia's word didn't work. Maybe hen. Oh, jog. She's clocked me. So, no. So you do have to click the submit button up at the top in order to get it to work. It is 2 apiece now. The rounds are up to best of 3. So whoever wins this round is going to win the game in total. So let's maybe go for Gab. Like, shut your Gab. And then hopefully... Oh, she's done beak. And that's it. So Nadia's won. And that's the end of the game. So I'm just going to leave and go back to the lobby. And that was a demonstration of our WormPlay game. So I hope you enjoyed it. We had a lot of fun making it. So yes.
Hi all, I'm Nadia and I'm here to talk to you about our WormPlay backend tech stack. So our backend was written purely in JavaScript. This is because it's something we'd learned at Northcoders. We were all very, very comfortable with the JavaScript language, so we chose to use JavaScript in our backend. Next, we created our server with Express. Now, Express is a HTTP server, and we implemented Axios, which allowed us to make them request to the Oxford Dictionary API and validate the words that were submitted. We also used Socket.io, and that allowed for us to have real-time communication between the backend server and the Phaser game. We hosted our backend with Heroku, and we chose Heroku because, again, we had used Heroku in a previous project and we were very comfortable with how we would implement and host our backend.
Hi, Chris here, and I'm going to be telling you about our front-end stack. We primarily used React and Phaser. Now, Phaser is an HTML rendering engine, and it's what creates our game. Patrick will be telling you more about this in a moment. We chose Phaser because, first, our research showed that it was one of the best tools for creating a two-dimensional game with physics, with interactable pieces, and secondly, because it was a brand new piece of technology for us, one that we hadn't learned on the course. At many points in this project, we really strived to adopt new pieces of technology, new libraries, new frameworks, and really broaden our horizons and push our limits in terms of how much we could learn in a short space of time and integrate together into one coherent application. So we also used React, as I mentioned, and we chose React because it's a single page application framework, and we wanted to simulate the experience of multiple pages, but ultimately it's one page that the user is accessing. So you go to the login, takes you to the lobby, takes you to the game, but it's just this one page. Because that also allows us to then render the game inside it and so on. And then finally, over here we've got TensorFlow, and this relates to our facial recognition, which I'll be talking about later. So, on to Patrick, and he'll tell you about the phaser.
So, to create the main gameplay element of WormPlay, we used a framework called Phaser 3. Now, Phaser 3 is a JavaScript framework for making 2D games in the browser using JavaScript and HTML that is mainly based around using the HTML canvas tag, in that it renders the game on a canvas tag. It is an object-oriented programming framework with inbuilt methods and classes that allow you to do a lot of things. For instance, game objects can interact with each other and with users, as you saw with the drag and drop letters earlier in the game. You can create animations to move things around the screen, as you saw with the moving worms. And you can even create scripted and timed events to happen. For example, the countdown that runs throughout the rounds, and the fact that a round ends when the countdown.
Hi, Chris here, and I'm going to tell you about facial recognition and data management. The first is about us breaking apart an existing piece of technology, and the second is about us building up our own custom framework. So, facial recognition. This was an existing API built on TensorFlow. It recognises what is a face, draws a blue box around it on the webcam, recognises who you are, what your emotion is. And we didn't want to just take this wholesale and slot it in. Instead, we wanted to open that box, break it apart and understand each individual part of it, how it worked and what it was doing. Because some parts of it we didn't want. Don't want it to recognise who you are. We're not going to use that in the project and might slow everything down. Can we get rid of that blue box around your face, just aesthetically? Although actually, we still need to use its coordinates so that it takes a photo of your face wherever you are on the screen to put on the worm. So this was a really enjoyable weekend-long spike of breaking apart this facial recognition tech, working out which bits to take out and which bits did what, and how to integrate that into our project. So, in addition to this, and the converse of it, we were also building up our own custom framework for data management. This was a key challenge that we had in this project. We really broadened our horizons by using a range of different technologies that were new to us, learning all about them, and we also faced the challenge of making them work together. In particular, Phaser, that shows you the game, React, that shows you everything else, the lobby, the chat, the login. Making these two work as one, pass data between each other in real time, immediately. This was something that we put a lot of time into researching. There's a lot of documentation on both, but not on both together. And so it was a very enjoyable process of each going off individually, doing our research, coming back, feeding back to the group, updating each other about where we were, building on top of each other's work, and eventually creating a structure that worked for us. A specific tree of where data is passed, when it is passed, which components are created inside which other components, and so on. And we made sure, for communication purposes, to extensively document this in our README file, so that all of us working on the project at any point, I'm working on something totally different, I'm working on the points, but I need to access the username. Well, that's from React, because that's from the login. Great, it's here in the README. Explicit instructions from the other team members about exactly where to find and how to access each of these pieces of data. So it was a really enjoyable challenge, and one that I think we did a really good job of bringing together these different pieces of technology that were new to us and integrating them together and passing data between them as one coherent application. So we had our facial recognition, breaking apart something existing, and our data management, building up our own custom framework. I'll pass you on now to Nadia, who will tell you about the sockets.
So I'm here to speak to you about Socket.io. Now, Socket.io allows for real-time communication between a server and a web browser. This enabled us to create some really cool features on our game, which include the instant messaging that you saw earlier in James's game demonstration. It enabled us to create Socket.io rooms, which means you can play against one person only. It allowed us to create the lobby area, which showed you all the available rooms that you can go and play in and whether they're full. And I've created a diagram here where you can see the relationship between the Socket.io in the backend server, the React Phaser app, and the client. So this helped us to create this real-time game where you can see the opponent's scores, you can see where the worm is on the opponent's screen, and you can see the word submissions in real time. So this is why we chose Socket.io, so we could make a great real-time game. We used the Oxford Dictionary API to validate every word that was submitted during gameplay. So we used sockets to display and record the scores of both players in real time. So I've created a little diagram which shows the process in which the word is submitted, and I'll talk you through that now. So initially, the word is submitted by the client in the Phaser game. Phaser uses a socket to emit the word to the server. And what the next step is, the server then makes a request to the API to validate that word. Now, upon validation, the score is updated and sent back to Phaser, and then Phaser displays the updated score and the message. So that's how the Oxford Dictionary API worked.
Due to current events, we had to develop WormPlay entirely remotely, whilst also maintaining agile development practices throughout. Needless to say, as this was the first major group project undertaken by any of us as developers, this created quite a challenge, and the added challenge of it being entirely remote was quite daunting at first. But we managed to make it work using a number of digital technologies. So for example, we used Trello as a virtual Kanban board that allowed us to create, assign and work through tickets and keep on top of how the project was progressing. We used Discord for voice chat and for twice daily stand-ups that allowed us to keep track of each other's progress and make sure that there were no issues that one person was being particularly stuck on. We also used Slack for regular group messaging, imaging, link sharing to share resources with each other that we thought we'd find helpful. And we used VS Code Live Share for pair and mob programming to help when people were particularly stuck, or just sometimes it was better to pair two heads are better than one. We also used Google Drive for tracking files and variable management across React states.
Hello, hi, my name's James. We're joining us here in my kitchen. I'm just going to talk you through some of the challenges that we had making our WormPlay game. So the first big challenge is that Phaser-free doesn't really mesh well with React. You kind of have to build a Phaser-free game and then embed React into it afterwards. And while we decided we were up to that challenge and we thought that we could do it, we didn't really stop and think whether or not we should do it. And later on, when it came to the pragmatics of hosting it, we really could have done more research earlier on to help avoid that. Another challenge that we had is that most of the technologies we decided as a user are actually brand new to us. So while we became very good at independently learning how to use these new technologies, making sure everyone else in the group was informed on how to use these technologies was a challenge in itself. The other thing that we had was that we used sockets and they were embedded into our Phaser, our React, and also the video feed. And getting these all to copacetically communicate between each other was another challenge as well. Lastly, tiny challenge was that we didn't really spike into file management for Phaser-free games. And so as our project became bigger and bigger, it became slightly more unwieldy as well. But that's it for me.
So for our final slide, I want to talk to you about some thoughts we've had for future development and some features that we would have implemented if we had more time. Now, there's a few things on this slide, so I'm just going to pick a few off to talk through. So first of all, we would have loved to have created this as a mobile app. Now, it's currently a desktop app, but we would have loved to have that feature for our game. Secondly, we would have loved to have had the webcam take pictures during gameplay. This was a feature we tried to implement initially, but it was slowing down the game and the user experience wasn't what we wanted it to be. So we decided to move that into the lobby area. So again, given more time, we would have loved to have implemented that feature during gameplay. And finally, we would have wanted to spike hosting earlier on in our project. We did leave this quite last minute and it caused us some issues, so we weren't able to do it in time. Again, if we were given a few more days, we would have been able to implement that and have that live in time for our project presentation. I'd like to say thank you for listening, and if you do have any questions, please leave them in the YouTube chat. We're all online at the moment, so we're able to respond. Thank you.
Thanks for watching, everyone. Don't forget to comment and like.